What's up, mga nunuk? Welcome to new video tutorial about ADB linked list. So right now I am down to the last deletion of a node. So this time I'm going to do deletion. So deletion at position is a little bit confusing because um, the algorithm would the algorithm is a little bit like confusing, as I've said. It's first is probably, um, so that you're able to delete the node at certain position, of course, you'll have to know up to which position. Okay, you have to know the position of the node first. So you'll have to have a while loop on that. Okay, and then after that one, you'll have another loop to visit that node, um, which is the same of what we did here. So meaning we get the address of that node that is visited. So instead of it is at the last node, of course it is the node at certain position. And then the last loop would be the loop to remove the remove the node at that certain position. So how do we do that? First is, of course, we'll have to have a like public. Okay, let's have here void. Sige, ato na lang ning sige, void na lang. Sige, I'll have here void. They add at sorry, delete at position. Position. So you have here in position, same with add position, but this time we're going to remove or delete the node. Okay, after that one, we have here the yeah, okay, that's it. And then, so as usual, we'll have to determine if our list is empty. So if it's empty, then um, we are going to display here that the list is empty. Okay. And then after that, we now go to the removal. Okay. So in the removal, you'll have to have here node that is going to have like visit. As usual, we'll have the link, and this time we'll need another variable. So this variable is going to be the last and final, not variable, but an instance of the L node that is actually going to hold the 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 address of that node that is deleted. Okay, that is about to be, or the node that is about to be deleted, that links to it. So meaning, before you delete it, you'll have to get the address of that node that that links to the node you delete. Okay, so that it would be difficult for us to link the node together again if there's one node that is being detached or one node that is being removed from the list. So let's name it like pointer. So this time we are going to assign this each of this what they call this one instance to visit is equal to pointer that is equal to null. Okay, so here comes our the first is we'll need to know the how many traversal, how many up to what node are we going to visit or traverse by having a variable. So let's have here starts at 0. Okay, and then this time we're now going to have the first loop. So this first loop would determine either up to how many traversal are we going to do in this particular in the list of nodes. So meaning we don't have to traverse the entire list. We only are going to traverse the the nodes up to that position, whatever the user is going uh, to pass through it. Okay, in this in this position. So you have your position. Okay, so position. Okay, then after that we can we now uh, visit the node. Okay, we use the visit. Okay, and then as usual, we'll have to increment or get the uh, address of that. So again, I mean again, no, as again and again, the this one means ano siya, is going to get the address of that node that we visited to, okay, or that we are about to visit. So for us to know the up to how many, we'll need to have a counter so that this is going to stop, of course. Okay, so we're now done with the first loop. So we now have determined our the node that is going to be visited is up to this position only. Now the next loop will be visiting the will be visiting that node, but this time as upon visiting the node of that list up to that position, it has to it has to get the address of that. Okay, so right after that, you'll have to delete now. Okay, anyway, so we'll do it like link. So sorry, so link that next is equal to not equal to visit. Okay, so until it is now equal to the address that we visited, the node that we have visited at a certain position, then it won't stop traversing the node. Okay, then this time we'll have here link that link. So this is in order for us to get the right address. Okay, so now that we already get the right address, all the next thing we do is we we will have another counter operation or counter variable, or we can actually use the counter, and this time we are going to reset is this to 0. So reset to 0, because again from there our CTR is like already it depends on what position is that. Let's say if the position is 5, then this therefore this will be like 5 probably. Is it 5? Yeah, probably like that. Now have here we need to reset to 0 so that we are not going to declare another variable, but it's up to you if you're going to declare another one. At this time, let's have another loop, and then this time we'll have to visit each of the node until the position now, which is last one, meaning until it is not going to visit until it is yeah, I mean until dili na niya until CTR is not going to be equal to the position, which is, let's say the position is 5 plus 1, which is 6. So we'll need to have plus 1 in order for us to insert that, delete that, what we call this one, that node on that specific position. Okay. So, okay. So after that, we are going to now use pointer. So the pointer now is going to get the address. Okay. So the address of that node, okay, of the node, and then uh, we are going to increment CTR plus plus so that this will stop. Okay, so we'll need to do this to so that it will stop at a certain position, but this time plus one. Okay, so plus one because the the next node to it is actually going to be it's I mean the node that you are about to delete and the node that is after that will break its link. So in order for us to not break the link that links between them, we'll have to visit uh, the next node or beside the node on the right side of the node that we delete in order for us to get the value of that or the address of that node. Okay, and that's what we actually did here. So right after that, we are now safe to actually remove the node by uh, making that or assigning that address that is read after now after the plus one. So meaning to say if you have the nodes like 5, 4, 5, 7, 1, and say 8, and then you're going to remove 7. Therefore, what will happen is that so since 7 will be removed, then therefore you'll have to include the node 1 in order for you to create a link to 5. So therefore, so that so 5 and 1 are going to be linked because you remove the node in between them. So you must not lose the link between the node, especially if you're going to delete the node at a certain position. With the first and the last, in the first, there's no delete at first kasi ang it's straightforward because you are going to just delete the head, and then you don't have to traverse because you know where the head is. No, you know where the head node is. Okay, so that's why there's no visiting of each node. So in add at last naman, you'll have to visit each node, and then you'll have to know the node at the last by uh, recognizing the node that points to null, and then after that, that's the time you delete, and then you'll have to um, you'll have to get the pointer of that last node, and um, then link it to the node right left, parang the node before it. Okay, so in the delete at position, you'll have to combine three. First is you'll have to combine the two. Instead of going to visit the nodes, all the nodes in that list, you'll have to only visit the node up to that position. Okay, first that's the first loop, and then after that, once you already recognizes the node at that position, meaning you're only going to visit at that specific node, you'll get the address of that node. So that's the second loop, and then after the third loop is actually going to visit the address, visit the node from the first node up to that node, wherein based on the position, but you'll have to visit the next node of the deleted node. Why? Because we'll need to get the address of the node next to it. So in order for us to again create a link between the node that is left. Okay? So kay mawala naman si 7, therefore we'll need to create a link between 5 and 1. And that's what we actually did here. Okay? So let's try if we are actually able to do the deletion. So let's say here, so delete at position. So let's say we're going to delete 2. So let's have here. Uh, let's not delete. Let's comment uh, comment mo lang. So let's say we are going to delete 0, 1, 2, so 7. So delete position at 2. So since this is void, we'll need to remove this them that print out that line. Need man need, no? So after that, oh, what happened? And then delete at position. So meaning the what happened? So next because visit is so let's check. Hmm, a counter is not. position visit. That visit is pointer, a visit link. Okay. Mm, okay, link that next. That's it. That's correct. What happened here? So the error is null pointer exception cannot read field next because visit is actually not. So mm, it that is okay. Just wait for a while. So since we are doing live coding here, mm, at that position, okay, um, 0, 1, 2, visit that next. Mm, mm, vis, visit, was link equal pointer. What? My goodness. Kasi null. Kaya pala, no? I never read it. Visit is null. So, it should be head. Sorry, I'm so sorry for that. It's just a typo error and I haven't seen actually this one. So anyway, there, before we actually balik tata, sorry for that. Let's run again. So we are going to remove 7. So it is at position 2 or 4. Let's run it. So 3, 5, 12, 15, and there. So the only problem with this one is, I guess there's a problem with this delete at position with delete at position. Same with I mean, see, let's try. Actually, not gonna try, but it can be. I can anticipate it that there will be probably parang problem with this one. Let's say mag-delete ta with 0 uh, there. So because delete 0 is actually we should not, we should not do the traversal since delete 0 is like delete at first. Yeah, so the only way for us to do this is, I mean, to resolve this is we'll just create an OR here. Pwede ta mag-OR, pwede ra pod ta mag-else if here, which is if position is actually equal to 0, and then you can have here delete at first. So I guess we can do that. Okay. I mean rather. So balik ta dire and then okay there. 3 is actually deleted. So there. So instead of 7, 3 is actually deleted. So that's it. Another problem for this one is if we are going to delete like the parang out of bounds na position, let's say 7, because currently we only have like current size is 5. So 1, 2, 3, 4, 5. So let's say for an instance, we delete position 7. So this would also create a problem. So in order for us to, resolve also this one, we can add another if condition. And there's actually a lot other things that you may encounter or you may not na mga problems along the way as you are writing the program. So with here, you can have, pwede ibaliktad na to si else if, or let's look for, ano na lang na to. Let's say, vision. for 0 is great, pwede position, pareha na nato ganina sa add at position. Like, position is less than 0, and then or position is greater than current size. So current size. And yeah, so let's run the program and there. So pwede na to butangan diri og let's not remove it here. So instead, we are actually going to display uh, position is not valid. Okay, let's run. Let's try rather. So 7 is not valid. So since this is like 5, let's try 5. Happen with this one. So let's try 5 daw. Okay, yun. Ay, may problem. Uh, 0, 1. Oo, kasi position 5 less than 0 or position greater than, okay. So kasi, meaning pag current size nila, dapat equals to current size. Kasi that's add at, dapat add at, delete at last na pa siya. Uh, yeah, so 5 is not valid. So if that is the case, then actually pwede nimo siya, if position is equal to current size, you can have like add at last. Okay? But again, you have, sorry, add at last, delete at last pala. Delete at last. But actually, since you have position is less than 0, meaning it should be if if the user enters -1 for position, so are you going to delete the last node? So dapat delete, no? Dapat invalid. So you can have another condition for that, or you can actually separate the condition, position, and kanina two compound expressions here. Okay, so I guess that would be all for now, and thank you guys for watching this video, and see you guys in my next tutorial. Bye bye.